In the upcoming presentation, Senthil Arumugam, Director of Apex Sales DEM Technology, Altair India, will talk on simulate soil machine and crop machine interactions to improve equipment performance and drive innovation.
Hello, everyone. Thank you very much for taking the time to join this session. My name is Senthil Arumugam from Altair, and today my topic is going to be on how agricultural equipment manufacturing companies drive innovation and improve their equipment performance by simulating soil machine and crop machine interactions. Okay, so let's get started. As mentioned, I am representing Altair. Altair is a NASDAQ-listed market-leading technology company headquartered in Troy, the US, with a global presence of 3,000 plus people spread over 86 countries across 86 offices across 25 different countries. So a multinational organization. So if you look at what we do, Altair's comprehensive solutions for data analytics and AI, CAE and HPC enable design and optimization of innovative and sustainable products and processes in an increasingly connected world. Okay. So we offer a range of market-leading technologies and tools within these verticals to help customers around the world. Today's focus is going to be on one such vertical offered by Altair that focuses on simulation of granular materials and how the industry is adopting this technology to drive innovation in improving the performance of farm machinery. So if you look at the challenges within this industry sector, tractors, implements, combines, forage harvesters are all designed to work with a wide range of bulk materials, such as crops, seeds, soils, etc. So ultimately, performance comes down to how efficiently machines interact with these materials, as these can impact the performance of the machine and its durability. Okay. However, it is extremely challenging to predict the behavior of these granular materials due to its complexity and variability. Okay. So, if you are looking at using physical prototyping or physical testing of new equipment designs, then it is quite expensive and limiting if the manufacturers miss a seasonal testing window due to adverse weather condition like monsoons or unexpected weather patterns. It can significantly delay the time to market for new designs. So the industry is highly competitive, and manufacturers are often driven to bring innovations to market before each harvest season. So a big challenge faced by the industry is to investigate new designs without increasing the manufacturing costs. So this is where Altair Edem comes into play. So Edem is a high-performance software for granular material simulation. It is powered by the state-of-the-art technology called discrete element method, also known as DEM. So Edem simulates and analyzes the behavior of granular materials such as crops, seeds, soil, grains, and powders, and provides crucial insight into how these materials interact with the geometry or the equipment in a range of operating conditions. At Altair, we understand that CAE tools used in isolation only give you a part of the picture. Driven by this, we have developed a range of multi-physics solutions inside of the Altair suite, allowing the designers and analysts to take a holistic approach rather than a siloed approach when designing such complex machinery. Okay. So, let's look at some of the benefits here. So, Edem can be used early in the design process to drive design decisions that can have a positive impact on the overall performance and reliability of agricultural machinery. it helps to avoid missing planting and testing cycles, saving time and money. It provides engineers with crucial insights into how these materials like crops, seeds, soil, etc., interact with the geometry or equipment, during a range of operations and process conditions. It enables engineers to investigate new designs without increasing the manufacturing costs. Because you can run a large number of these virtual simulations, you're able to test these designs virtually before producing the physical prototypes for field tests. Another big benefit, comes up as a result of these simulations is the repeatability. When you get working in a virtual environment, because material models these material models you're going to use are predefined, and they have a very repeatable test environment to compare results between design iterations. Something which cannot be guaranteed with physical testing. As I said, the industry is highly competitive, and the manufacturers are driven to bring innovations to the market before each harvest season. So the use of Altair Edem technology has allowed companies in this sector to come up with innovations and reduce the reliance on prototyping. So these are some of the applications listed here, and we will cover a few of those today and how customers are, or how farm machinery companies are utilizing them. So first, let's look at grain and crop handling systems, specifically focusing on combine harvesters. The Indian combine harvester market is projected to grow at about 5% during the next few years. Combine harvesters in India are majorly used for harvesting grains and cereals when compared to the other types of crops in the country. So according to a recent research, the market for combine harvesters in India is dominated by self-propelled combine harvesters. More than 50% of harvesting of wheat and rice in India is already mechanized. So this is where the industry is focusing on driving innovation and efficiency. Okay. So, let's consider the typical process within a combine harvester where such advanced technology like Altair Edem can be utilized. One of the one of the process inside the combine harvester is sieving. Sieving is a very important step that separates the grain from unwanted plant material. So Altair Edem technology can be used to assess sieving throughput, compare different sieve designs in a range of different operating conditions. For example, you can look at a number of different sieve designs and modify the frequency that the sieve is vibrated at to find the best design and operating conditions for maximum throughput. So this kind of virtual prototyping allows you, not only to innovate, but also to avoid missing testing cycles and due to adverse weather conditions like monsoons, resulting in additional substantial time and money savings. Another application within a combine harvester is straw chopping process. So the cutting of threshed straw and its uniform distribution is very important. Any stock cutting operation requires energy. And the shorter the straw is chopped, the more cuts are needed and more power is required. So Edem can be used to compare these different designs and predict how these designs influence the straw orientation and improved chopping quality. And as a result, also improved power consumption as well. So all these have a direct impact into the ultimate performance of the machinery. So another process, that can be studied with Edem is screw augers. In the case of combine harvesters, they are used to transport grains into a bin. Here in this particular case, the hopper is filled with the material representing grain. Then the screw augers, one horizontal and one angled into the vertical direction, begin rotating, and you can see the grain begin to be transported. The grains are then displayed by velocity and mass flow rate. Just some of the types of visualizations you can do using these kind of simulation technologies. So we've had users who optimize the screw auger by changing the size, speed of rotation, and has resulted in 99% of the material going into the bin as required, whereas previously, before simulation, with the old designs, only almost 40% of the material went onto the field rather than onto the bin. It also helped them to reduce loads by 50%, reduced wear, reduced damage to the actual geometry or equipment, reduced energy consumption, and reduced damage to the crop. And as I mentioned earlier, Edem can be combined with other CAE tools such as FEA analysis. And we have some great Altair FEA tools within the portfolio. Within a combined harvester, a hopper full of grain type material empties over time. And the contact forces from Edem are mapped onto the FEA mesh. You can certainly notice the fidelity of the force input that the technology can provide. Alternative methods would require you to completely overlook the real loading scenario. So these are the advantages that the technology, simulation technologies, brings in, to design some of these complex farm machinery. So let us look at one of the most important process, threshing. It is one of the most critical parts of the within the combined harvester, and often poorly understood due to its complexities. So Altair has a simulation or a great solution from modeling granular materials using Altair Edem, as well as modeling the airflow using Altair CFD in a coupled environment to solve this kind of complex problem. The airflow blowing off the chaff is modeled in Altair CFD. Since the modeling includes the movement of the screen through which the straw and grains are filtered, a more realistic flow can be created. The two models created in this way can be analyzed through a two-way coupling between DEM and CFD. As you can see, the relatively light grain material is blown away by the wind. And in the case of relatively heavy grains, you can see that they go down without being blown away by the airflow. So, advanced analysis can be performed to make complex engineering decisions. Looking at the analysis, it can be predicted that by controlling the movement pattern, velocity of airflow, we can influence greatly the separation efficiency. Okay, so these are the kind of in-depth analysis that we can actually get into earlier. Otherwise, it would have been a black box when designing some of these complex pieces of equipment. Okay, so let's move on to the next example. This video, what you're seeing here, shows an agricultural machine that breaks moved grass into windrows. Complex materials like the grass and other fibrous materials and interaction with the equipment can be simulated using Edem and the other simulation technologies. What are you looking at? As mentioned earlier, it is important to take a holistic approach when modeling such processes. So in this example, we are looking at ways to optimize the liner rake performance by simulating the full tractor and the motion of the equipment, and to understand the machine dynamic response under different scenarios. For instance, the force required to move the system for different types of crops. Okay, so as you can see in this example, Altair offers the full portfolio, whereby Edem provides realistic loads data and areas where the equipment is likely to wear. And by coupling Edem technology with Altair Multibody Dynamics motion solve technology, it is possible to understand the global dynamics of the system. Here you can see a system model that can represent the real world scenario by estimating the power consumption by the rotors. Okay. So let's move on to the next section. Here we are going to look at some examples of machine-soil interaction. In India, mechanization is concentrated on tillage and seedbed preparation and harvesting. In tillage, old types of equipment such as cultivators and disc plows are still used. According to a recent study, the use of proper equipment can increase the crop productivity by up to 30% and reduce the cost by about 20%. And these are substantial numbers that we are talking about, and how to achieve those numbers. Improved efficiency and better productivity of the tillage tools are extremely important to meet the growing demands of the industry. So in the case of equipment tillage, the blades might be interacting with a range of soils across the country, with different levels of compressibility and stickiness, or perhaps even harder materials like rocks, all of which will have an impact on the durability as well as the performance of the machine. So being able to predict the how the equipment will be affected by a specific material and identifying potential wear on the tools represents a key aspect to ensure the machines will perform as expected. So in the next example, I'll show you the single shaft rotavator. So a rotavator is an agricultural implement used to prepare the soil for turning the soil at depth. So several in-depth analyses are shown here, from pulverization quality, voidage measurement, before and after operation, draft force, vertical force, torque on acting on the rotavator, through to the power required to operate at a desired depth of cut. So using these state-of-the-art simulation technologies, manufacturers can reduce the number of prototypes as well as come up with a solution during the right season. Trying out different blade profiles, different operations takes too much time if they go to field testing for every single configuration. So reducing 2 passes of soil tillage to 1 pass and identifying the different depth of cut and soil pulverization for different types of blade geometry all have a direct impact on the time taken for acre per hour and ultimately the fuel consumption. Using simulation, there is no influence on weather and seasons in product development. You can do A to B product comparison with the same boundary condition, but with less costs and faster build of prototype. Better visual understanding of the black box inside the machines are some of the key business benefits for the farm machinery manufacturers. So here is an example of using the full Altair solution for a tractor tillage operation. So users can estimate the torque required to pull the full tillage equipment under different soil conditions. Here, of course, we are taking advantage of 3 different Altair tools. Edem for granular material, in this case, but soil. Motion solve for multibody dynamics looking at the dynamics, the vehicle dynamics of the tractor system, and activate for modeling the actuators and the control systems. So an Edem can provide, of course, different soil conditions and provide them with the realistic loads data. So now you're able to look at the holistic approach or take a holistic approach in modeling such full system solutions. Another sector or segment, I would say, where Altair solutions can be deployed is to understand tractor mobility, looking at tire-soil interaction. Being able to predict dynamic behavior of vehicles when interacting with soil is crucial for understanding ultimately how these machines will perform in a range of operating conditions. So this is where Altair have a groundbreaking technology developed by our partners, Pratt and Miller Engineering, to model flexible tires. Flexible tires are important, especially within the agricultural tractor segment, focusing on tractor tires interacting with mud and soft soil. It is very important for any kind of off-road vehicles, especially for the development of ABS, TCS, central tire inflation systems, etc. So let's look at a comparison between a rigid tire and a flex tire under the same soil terrain condition. On the left, the high pressure tractor tire has a deep bulldozing effect with a bigger penetration on the rigid wheel. On the right, low pressure tire that can float over the soil with half the penetration. So this is very important. As you can see, there is not only a significant difference in the resistance, but also a clear differentiator and indicator from an energy fuel consumption standpoint. So this is very important to understand how to improve some of these designs. As mentioned, when used in conjunction with Altair MBD solution, Multibody Dynamics code, it allows the tractor OEMs to study the full vehicle behavior, mobility resistance, traction controls, power required, TCS and ABS development. It can also be used to study pressure distribution, grip, tread pattern, soil pressure, soil damage, seeds damage, etc. So all these things are possible, and it's very important to actually make sure that the tire deformability is taken into account in the development of tractors, and that's very important. So finally, companies are moving towards digital twin solutions, and Altair's know-how is helping companies around the world support with this digital transformation. New digital solutions must allow you to strengthen the link between simulation and physical model in order to take advantage of both worlds in favor of the product you design. These state-of-the-art simulation technologies that I talked about earlier can be powered, nurtured, enriched with real-world data. And we have the solutions to organize, prepare, clean, make them talk, to get the best out of them, and build smart models that will ultimately improve the performance of your product. So with this, I would like to end my talk, and I hope my presentation was helpful in understanding how farm machinery companies can utilize some of the simulation technologies, latest simulation technologies, to innovate and reduce the time to take into to market some of the new products. Okay. So thank you very much. Stay safe.
Thank you, Mr. Arumugam, for a precise and informative presentation. Now let's move to the next session. Stay tuned.